Okay, in this segment we will allow or ask Excel to help us plot in a line that best fits our data, and we have to do some of the decision making ahead of time, and that in this case involves looking at uh, possibilities for the pattern in the data, and it looks like the data is curving up steeper and steeper as it goes from left to right, as opposed to a straight line, which we call this path. So it looks like there's going to be some polynomial function here. Probably we're hoping for an x squared ratio or relationship. So what we'll do is right click on one of the average data points, which is this yellow one that's hiding behind here, and I'm going to right click on it. Well, let me go back here. If I hover the mouse over each data point, it will, the yellow or tan box will show us which data point I'm over, and so I want to make sure I'm over one that says the average of the 45 Newton trials. And I'll right click, and what I want to do is add a trend line. That's Excel's version, or what they call a line of best fits. We'll add the trend line. I'll click that option. Remember, so we needed to look ahead, and we have just a few choices in this case. One would be a straight line, one would be a polynomial, and the other would be a moving average. Well, what we want is the best fit line with the simplest expression, so we'll try a polynomial. Second order means that it's squared, which will give us a parabola. Third order, of course, would be cubic and would be more the shape that's shown on the screen. Fourth order would be a quartic, which would look like a parabola but would have a little square or corner to the bottom. So anyway, second order, and bring the dialog box up where we can see it, and we'll click, before we click OK, let's save ourselves some future mouse clicks. And one of the options, so I'll choose the Options tab here, one of the options that I want is for Excel to display the equation on the chart, because we're going to tie this equation back later to something we've learned in class with kinematics. We could display the r-squared value to see how close the fit is, and we could force the y-intercept to be 0. But in this case, just want to display the equation on the chart, and we'll click OK. And here is our trend line, best fit line, and its equation, and I'm going to move the equation up here where we can read it, and it's in the form of ax squared plus bx plus c that the students have been learning in algebra class. And in terms of our experiment here, this the a coefficient is actually half the acceleration, so this is telling us that the acceleration for this average of trials should be somewhere around 0.25 meters per second squared. So it's 1/2 at squared plus v naught t, and this would be the starting position. So you can see that our best fit line doesn't quite hit 0, and says that we had some amount of starting velocity, which of course is probably not true, but this is the line that Excel has chosen to best fit the data. So we'll leave it at that.